Hey, what's up, Ziguanas? This is day 2 of the 30 days of Zig coding challenge. I invite you again to join me as I apply over 2 decades of professional programming experience and around 15 years of code teaching experience to master a new language. My name is Dusan. Welcome to United. Okay, so let's start. Yesterday I have seen the video that I made yesterday, and I noticed that I have missed something. So when I tried to use numbers here to print them out, I got an error, but I completely missed the thing that these two string interpolations are different. So I missed this S completely. I don't know how. I haven't seen it, and that's why it actually didn't work. So I tried later offline, and you can actually print numbers as long as you don't put the S. So let me explain what I meant. So here, instead of this, if we put a number and run it, this should work. Okay, so yeah, okay, this is because I left this text here, but the point is that the number shows. So this is what I missed yesterday. Somehow I didn't see that here I had this S because I deleted this part yesterday. So I tried to replace only the first parameter here with the number, so this string world, and it didn't work. And this is the reason. So basically, if I do it, let me do it again. So let's leave, we can leave it like this so that we have 1 in the first place and also in the second. So because of this first one, it actually said invalid format string S, but I didn't make the connection because I'm new to the language, so I don't know. I didn't know anything about it. Then I actually saw this S here, and I figured out it's when you format string. And also when I played, I've got some different error. I played with it a little bit yesterday, and I got some other type, any type. So I forgot what I exactly did, but I did change. I tried to inject different things here, and I got another error. So as far as I know so far, I mean what I've tried so far, you can inject at least 3 types of data here. So you can inject the string like what we had here, the string literal world. We can inject numbers, and basically that third any type, theoretical, could be anything because it's called any, but we will see. So I don't want to spend time now on these types. Today I want to focus on integers, but I just wanted to see how I can print integers in the first place, so how I can see them on the screen. And we don't need this. So yesterday I've seen that it's used just to show the version of Zig, so we don't need this. Okay, so without S it can print numbers, with S it just expects strings. And by the way, it looks like that actually there is a string literal. So yesterday when I was going through the types, so the summary that was made by the AI, it said that there are no, officially that there is no string type in Zig. So they call it, I think, slice, not an array. I think it's called the byte slice or something like that. And it looks like that actually they have these string literals, so maybe not the type itself, but the literal is there. So we'll see, but not today. So today I'm going to focus on numbers, on integers. And this is also something that I went through yesterday. So the official ziglang.org, so the official documentation for Zig, and I was here. And this first part just speaks about installing Zig, and I remember seeing, yeah, here. Next steps, check out other resources present in the Learn section. And what is the version of Zig? 0.14. Okay, so this is the one. So let's see the language reference. Let's start here. So hello world, we already went through it. Let's see comments. Okay, this is pretty standard. I skipped that part because it was obvious from here that it supports the standard 2/ comments, single line comments. And I don't see here that they have multi-line comments. So they say they support 3 types of comments. Doc comments, okay, this is also interesting for later, not for now. And top level doc, okay, yeah, so we'll go through that later. I just want to go, because there are so many things, and I want to start with the numbers. So let's actually see what they say here in the value section. And let me zoom in a little bit, because this is probably not so visible on, they're zooming the wrong part. Okay, because this is probably not so visible on the mobile phone. If someone is watching on the mobile cell phone. So yes, we were here, values. Okay, top level declarations are order independent. So I see they have const. I didn't see any variables yet. Let's see, they have a huge main function. And they create again one constant here. The type is integer 32 bits. They assign the expression. Okay, so this is executed first. It's evaluated to 2, and then this gets the value of 2. Then let's copy paste this code. Let's just try immediately. So I will leave this hello world. I will just comment it out. Aha, okay, because they're imported in a different way. So we can do this actually. I don't want to change for now and to go deeper into how to use this. They just imported the namespace, but I don't want to do that now. I just want to keep it simple and focus on numbers. Okay, yeah. That's pretty straightforward. Floats, booleans, okay. Optional value. Aha, okay, so here is how they declare variables. This is the first variable that I see. Aha, they use this optional. I remember this from yesterday. But let's see if we can just, it should be possible just to create the variable, so I don't even have to copy paste from here. I will do the same here. Let's go here. Now let's change this to var just to see. So let's say x, it doesn't matter, and let's say it's 5, and let's try to print it out. No, we don't need this. We can say x equals, and then x here. Aha, it's never mutated. Aha, okay, understand. So there is something similar in other languages. So it looks like if I don't change the value, it cannot be var. It has to be const. So this will work. I know this will work. This is easy, but I actually want to try to change the value of the x and see how it will work. I mean, probably it's there in the documentation, but I like to experiment on my own just to see how things work. Okay, yeah, of course this works, but let's get that same error again. I want to read it one more time. Local variable is never mutated. Okay, let's try to mutate. If we say var x equals 5, and let's say x equals any other value, let's see now. Yeah, now it works. Yeah, I see this for the first time, something like this. Okay, it's interesting. Let's now try to use, I remember their standard sizes of the integers from 8 to 128 bits, the standard ones, and they have some unstandard, I forgot which ones. I know that you can basically do i7 if you want, but there was something, maybe the float, yeah, the float was F80. But when it comes to integers, let's try to play with these. So this should be maxed out as 127, so this should be fine. And let's see if we try to do 128 after. Here, for example, if I try to change it to 128, should be an error. Yeah. Presentation, so it will not upgrade automatically to some other type. So I guess it's always the same type, that we cannot change it. I mean, we don't know. I don't know. We'll see. Maybe it is even possible to do something like a shadowing or something similar. But at least in this way, it will not do anything automatically. It will not change the type. It will just panic. It will cause an error. Okay. So I guess if we put this to i16 now, it's going to work fine. Yeah. And let's see, by the way, okay, this is literally what I wanted to search for now. Let's see how we use the type of, or the import, do the import type of. No, it looks like when they use this at signed, it is something like a directive or something that is already built in. So I want to see what is the type. I mean, I know here in this case what is the type because I define it here, but I just want to see how it will tell us what is the type. So let's do it here. I will do X and then the type of, and then X, if this will work. I don't know, I didn't see that they import it anywhere. So they just import std debug. Okay. Yeah, so let's try. And of course, then I will need another, this is the X, and then let's say type of X is equal to, and then the next pair of curly braces, and then this is the next. By the way, because I have experience with the several programming languages, I can go faster through all these things, which are maybe confusing to some beginners. And that is actually the point of this series of this live streams that I'm making, the 30 days challenge. So if someone who is, let's say, beginner or not so advanced thinks that this is too fast and they cannot understand anything, write me down in the comments, so I will then maybe in parallel with these 30 videos that I planned to do, maybe I will make some additional explanation videos for the people who cannot follow up. So I will explain literally like all the details, like it's someone's first programming language, if someone doesn't have any clue what I'm talking about. But I'm just like trying to show how I think with my experience and how I approach learning a new language and how I test things, how I try to do it practically. So I mentioned this, that I think it's very important to do practice. So I can of course read first all this, and I can then do these examples that they have, and then just later in some time practice. But I try to practice as soon as possible, to hack things on my own, to just try to go through the language and to let it go through my fingers so that I can learn it better and faster. So if you guys want me to explain things in details, I will in parallel start streaming some basic explanations. So I will literally like comment on, I will watch this video that I'm making now, that I'm streaming, and I will comment exactly what I meant and all the details. Okay, let's continue. Let's try to run this now. Okay, this is good. So this type of whatever it is, macro, I don't know what it is now. It directive, I don't know. So we'll see. But we can use it to see the type of anything. So it just tells us what is the type. And I want to see what is the type of string as well, because they say, actually AI said that there is no such type. But let's see if we put a string literal here. So let's say type of hello, it doesn't matter what it is. And let's just do the type here. And here, let's do type of, and then hello. I'm just curious if it will say string or something like a slice of bytes or what the AI said. Yeah, this looks like a slice of bytes. It's not a string. And this, I guess it's a pointer, a constant pointer or pointer to the constant slice of bytes. Okay, so I mean, this is not the topic of today, and I was just curious because I remember this. So definitely they have string literals, but under the hood, when it comes in, the type itself, it's a slice of bytes. So the string as type doesn't exist. That's interesting. Okay, what I wanted to do here. So yes, I remember there are like sizes I8, 16, 32, 64, and 128, and also the unsigned integers. So let's try to see, I guess the operations are standard. We already saw here the plus operator. So let's just try to play with operators. I guess they have all the standard ones, but just to see what operations we can do with numbers. So let's say here 1 plus 1. Actually, we already had this. Yeah, but I didn't use. I used the expression that I assigned to the variable, but I didn't try to do here directly the expression. Let's see. I guess it will work, but just to check. Yeah. Okay. So let's try a few more regular ones. So subtraction should work. So let's skip also to, I guess this is multiplication standard like in other languages. And let's do the division. Let's try to divide and here to multiply with these standard operators and see if we're going to have some problems. No problem. So 1 minus 1 is 0, 1 times 1, 1, 1 divided by 1, it's 1. Okay, let's see if there is something like in Python, for example, integer division with 2 slashes. Yeah, so this this is immediately the comment, because in Python the comments are hashtags. Okay, yeah, so this doesn't work. Let's see the modulus operator, and let's do something more interesting. Yeah, okay, this is running pretty much standard. Let's see how we can do the powers. Can we do 2 stars like in Python? No. Okay. This operator multiplies. This is interesting. So I discovered an operator, but it does a different thing than what I expected. Okay. Let's try if I can find it on my keyboard here. Yeah, this one. Let's try if this will do the powers. it's something different. So this is not 10 to the power of 3, definitely. What is this? Oh, I don't understand. What is 9? Okay. So let's see here if we have the operators. I just want to go find quickly. Okay. Let's see here. Okay, they have some exotic ones here. I will come back to that. Okay, this is bitwise. We don't want to do that now. Array multiplication. Yeah, this is what I discovered by accident. Wait, I missed this one. Let me try to search for it. I didn't see it here. Aha, here it is, bitwise. Aha, this is, yeah, okay, yes, of course. It's also in many different programming languages, but it slipped my mind, of course, XOR. Bitwise, okay. So let's see if there is powers operator. I didn't see it. No, that's all. Okay, so no powers operator. This is XOR, so now it makes sense why it's binary, zeros and ones. Okay. Let me actually go here to the operators. I just want to go quickly through the integer operators. So this is addition with assignment, wrapping addition. What this does? Just go with wrapping behavior, invokes peer type resolution for operands. Okay, I will have to research this. This is something new. I've never seen this before. This is okay. Again, something new. Wrapping negation. Two's complement. Okay. So this is, I guess, binary arithmetics. Saturating multiplication. This is, I will try this and I will see what it does. It's very interesting. I've never seen these. Remainder of division. Okay, this we tried. Okay, these are bitwise. I don't want those. Bitwise. Unwrap. Logical. Aha, this is like in Python. It's words instead of characters. Yeah, I don't see any more. Yeah, these are all. So these are all integer operators. There aren't any others. So basically that's it for integers. These are all of the operators and that's it. No, I mean, except for these that I really don't understand and I don't want to waste your time now. Maybe I'll do this offline, or maybe because I kind of like to avoid doing things on my own. I want to document everything that I go through. So I'll think about it if I will do a research on this online. I mean, not online, live in stream, or I will do it on my own. So for now, I'm just going to ignore it. I don't know what that is. So let's see floats because they share the same operators. Actually, let me just jump quickly to integers just to see if there is something interesting. Okay, this is hexadecimal representation here. Octal. Binary, this is also like in some other languages, nothing new. Again, also something that you have in many different languages, this separation for just like the visual, so that you can understand the number easier, read it in an easier way. Integer values, integer literals have no size limitation. Okay, this is specific to literals, not for the values we assign to variables. And if any illegal behavior occurs, the compiler catches it. Okay, the integer value is no longer known at compile time. It must have a known size, and it is vulnerable to safety check. Okay, illegal behavior. Divide, time, okay. These function values and B are known only at runtime. Okay. Is vulnerable. Okay, yes, of course, it can happen. The overflow and division by 0 both. Aha, this is now. So by accident, I stumbled upon the explanation. So these additional percent signs that they have on in the addition to other operators. So this, how they call it saturating and so on. This is to prevent the overflow. Okay, wrapping arithmetic as well plus perform saturating arithmetic. Okay. So this is about the overflow. Okay, got it now. Between integers. Yeah, these are the weird ones. Okay, this is interesting. So let's see the floats. Yeah, by the way, here with integers, they didn't list them here. So I thought that I missed, but it's not there. And they do list these guys, floats. So standard, are a little bit unusual, and this is very, very weird. There has to be a reason why they support this F80, 80 bits. And this C long double, this is for the long double for the interface of C, or the integration with C. Okay. Let's see about the literals. Yeah, by the way, let me see something. Can I just do the type of here, the number? I just want to see the default if I don't assign it to a variable. But if I just say the literal itself, let's say 1, and let's see the type. So if I don't use the variable, if I just use the literal, okay, this is my mistake. Okay, let's see. Comp time it. Aha, this is comp time integer. That's what they said. Okay. So they don't use these literals. They don't specify. Yeah, that's literally what they said. They literally said that here. So basically, if you have a literal, it's not like in some other languages that you have some default size, like i32 or i64, but you rather have the unsized compile time integer, which is basically unspecified size, and then during the runtime, it will actually get some size. Okay, now that is clear as well. So I guess this is also the same with floats. Let's do float. By the way, let's see if we can make a float if we just add a dot. Or I have to put something behind the dot. Yeah, I cannot. So let's try this 0 after the dot. Yeah, now it works, and it's, yeah, comp time float. Okay, now this is clear. What is comp time? I was wondering about those yesterday when I first read about them, but now it makes sense. Okay, so let's see here. Standard types, not so standard. Let's see what else they say. They're guaranteed to have the largest precision. Okay. Okay, this is interesting. So even if you use a float like I did here, which doesn't have anything after the decimal point, they will actually coerce that into integers during the runtime. Okay, that's interesting. These are some examples with floats. Again, the hexadecimal floats and the underscores for separation. Okay, there is no syntax for NaN infinity or negative infinity for these special values. One must use standard library. Okay, okay. Okay. So there is no value basically that is NaN or infinity like in some languages, but you have to actually call this standard math library and then take the infinity or NaN if you want, not a number. Okay. Input operations. Okay, this is just shifting. Separate code into two object files, otherwise the optimizer figures out all the values at compile time, which operates in strict mode. Okay, we don't care about those at this moment. I just want to double check here one more time the operators for floats this time. Yeah, that was pretty much everything. Yeah, so how they use, I see here they just mention integers, but I've seen this operator up there with floats. What they do here? No, this is integer. Okay, so this is literal, that is integer. This is also integer. Okay, I guess this converts, okay. So I guess what they do here, they're shifting one to the left 40 places, which is then 1 and then 40 zeros in binary, and then they convert it to float. Let's just see this line, what it does. I just want to see if I guessed correct. So I just want to see the type of this thing. So let's do first type of big. So if it's what I think it is, it should be float. Yeah, and let's do smaller shifting. Let's shift one, let's do 3 times to the left. So this should be then 1 and then 3 zeros, right? So we can do that instead. And I actually wanted to print it out just to see. And that should be 8, right, in binary. So 1 and 3 zeros, 8 in binary. Let's just see if I print. So we can say here, big equals, and then this. And then here we can add the big variable here. So we expect to see 8 as a float. So 8.0 or something like that. Okay, they use the scientific notation here. So 8 and times 10 to the power of 0, right? This is a0. So 8 basically. It's a float, but it's interesting that they by default use the scientific notation to display floats. Okay. So nice. Today we found out about type of. This is one of my favorite functions, methods, or whatever it is here. In other programming language, somewhere it's called type, somewhere it's called type of. But it tells you the type of anything. Very, very useful, especially at the beginning if you don't understand what you're going to get from some function as a return value or something similar. And this is, I was also wondering how you can convert types, do the typecasting. Let's try to do something here. So can I force an integer? So let's do this. Can I make this, so let's say integer example. So let's try to do this. Let's try to say 128 as I8. So can I force it to go to the smaller type? Let's see if this is going to break or it is going to. Okay, this is different. Unused local constant. I have to, okay, I have to literally use it, so I have to at least print it. So let's say, this is interesting. There are also some other languages that do this. They force you to use something if you define it. So let's just say here, for example, and we don't care about the type in this case. And here we just have integer example. What is the error? Okay, so so now this is what I actually wanted to test. So it will not allow you to cast the larger type into the smaller one. At least not by default. Maybe there is some flag or something that I can use to force it. Still don't know. Something like unsafe or something. But in this case, it doesn't work by default out of the box. So let's try to do the opposite. Let's try to do, let's say this is I8. And let's try to convert this to 16. So I guess this is going to work. I don't see why it wouldn't. Okay. Yeah, and let's try to cast, for example, float point. I guess it is going to work because they also say here that they do it automatically. So I don't see the reason why this shouldn't work if you don't have any decimal numbers after the decimal point. Yeah, this works. Nice. And I guess if I do this, it's going to break. Yeah. Okay. That makes sense. So we now have a better understanding how numbers work. Let's see if there is something else in floats that might be interesting. Set float mode, optimize. So I'm not going to go into that much into details this time about floats. Then we have the operators. What's after arrays? No. So this is basically, these are the basics of numbers, let's say. So I can stop here. I don't want this video to be too long. So I will continue tomorrow. Tomorrow I will see what I can do with these strings. String literals to be specific. And I want to see the standard things. So getting the size of a string and so on. I want to play with strings a little bit tomorrow before I continue to other types. Okay, that would be everything I had in mind for today, even more than I had in mind. I didn't think I'm going to cover floats at all, but I did. So nice. Okay, thank you guys. Thanks everyone for being here, and see you in the next one. Bye bye.